So here we go. Welcome to Handmade Hero, the only show where we code a complete game live on stream. And you know, E3 is going on right now, and you may wonder how come none of the big press conferences like Sony and Microsoft and Electronic Arts and Nintendo, how come none of them have announced Handmade Hero for their platform? And the reason is because they're just too intimidated by how awesome our code is right now, and they're like, we don't want this Handmade Hero software renderer stuff that they did we don't want people to find out about this, because if they find out about this, they're just gonna look and go, oh my god, like, we didn't need an Xbox One. We could have done all this on an Xbox 360, right? Or whatever. And they don't want that. So they're trying to keep it under wraps as much as possible. But what can I say? We're still here, and we're still doing this optimization, and we're still making some pretty amazing stuff. And eventually they're just going to have to recognize that and come to terms with it. But we'll let them do that on their time, because we don't want to push them to accept something before they're ready. That's just a recipe for disaster. So we'll just keep going, and then next year's E3 clearly will be the year where, pretty much, I don't want to say definitively, but pretty much all three platform vendors are going to have to announce a Handmade Hero for their platform. Otherwise, are they really going to be relevant at that point? Probably not. So anyway, we'll keep an eye on that as it unfolds. But for the meantime, we do have some work to do here. Before I jump into it, let me simply say that we are on day 137, so unpack day 136's source code if you want to follow along with where I am. And where I am today is we got our asset system working pretty fancily, actually. And we have got quite a bit of things happening now that are pretty cool. But there was one big missing piece in our asset system so far that we had to take care of, and you can see we left it in there as a bug at the end of last stream. You can see it happening right now. Like when I'm moving down, it's not picking the right asset, and we knew why that was even ahead of time. I had said that it would happen, and it did. The reason is because we do not have matching of values in our tag system on periodic boundaries. And so when you get something like an angle that's periodic, it does not know how to match the closest thing, and we need to fix that. So why don't we spend a little bit of time on the Blackboard today just talking about exactly what's going on here, and then how we can fix it, right? So let's take a look here. I'm going to go ahead and close that down. So let's just get the Blackboard going. So here we are on day 137. And so we want to do periodic tag matching. And I believe it was Chocolate Dino who suggested yesterday, a very good suggestion, if I do say so myself, which is that in order to handle all tags uniformly, perhaps we could simply introduce the concept that all tags were periodic, and the ones that we didn't actually want to treat as periodic, we would simply give a large period. And so I think that's a pretty good idea. So first, let me just explain exactly what we're dealing with here, and then I'm going to maybe work out a little bit here how we might do exactly that, which is to have everything have a period, but just set it large so that it wouldn't affect things that we didn't want to be periodic. And we'll see how that goes. Okay, so what's our problem? Our problem here is that we are using a function called atan2, right? We used it yesterday, and what atan2 does is it maps from a direction vector, right? So it takes one of these little xy vectors that we had, in, like our velocity, right? And it can basically turn that direction vector that we've got into an angle, right? Some angle that says what direction something is facing, and that's a very useful thing for us to have, because it gives us a scalar that we can use as a tag value to match against, so that we can just dump sprites into our asset library at any angle, and they'll automatically get picked out depending on what angle the player is moving, or anything else is moving that we want to use this sort of technique for, right? But the problem is, as this spins around, right, it's periodic, meaning if we were to rotate 360 degrees, we would be back at where we started. We would not be at some other angle. And what that means is that we need to make sure that when we do matching, we can't simply look at the scalar value and say, oh, this scalar value is 0 and this other scalar value is 360. Those are very far apart, so they probably don't match. We can't say that because actually these are the same, right? And so we need some way of determining that these things are actually very proximal to each other, even though the numbers appear very different, and that is the periodic part of it. Now, what we know about A tan 2 is that the range of A tan 2, it actually gives us back numbers that are symmetric around 0. So if this is theta equals 0, what A tan 2 actually gives us back is not 360 degrees of rotation, but rather it gives us back negative 180 and 180. So it gives us back 180 degrees of rotation this way, and it gives us back negative 180 degrees this way. And of course, if you want to talk about that in terms of radians, it's pi radians backwards, or pi radians counterclockwise and negative pi radians clockwise from the sort of positive y-axis this way, right? So what that means is we want to encode our animation, our asset matching to be pi and negative pi, but we want, we want them to be marked that way. So we'd have like something at 0, something at, half pi, something at pi, and something at negative half pi. But then we would want things at negative pi, for example, to match against the pi things, and so on, right? So we want that to work relatively well. Now, this is a pretty easy thing to talk about in terms of how we might parameterize this, right? You could easily see us encoding this as saying, okay, this parameter has a period of pi, right? And what we could say by that is it means it goes from negative pi to positive pi. That could be our encoding. So they're always symmetric about 0, and they go from negative to positive some value, and that value is the range, right? So that'd be pretty easy. And then if we had some other values that we didn't want to be periodic, we could simply say that they ranged from like negative 100,000, to positive 100,000, or some really large number that we knew would not interfere at all with the numbers that we wanted to encode. And as long as that was at least twice as big as whatever the biggest numbers we were trying to encode were, we would really be in no danger of introducing any kind of false matching. So that's not a bad idea. The question is, if we were to actually do this encoding those ranges is pretty easy. How do we actually do the matching? And so if we have something here, and we've got something here, right, like an angle A that comes in, or we have something here that's an angle B that comes in, and we want to match it against something that was set here as being a value pi, how do we actually do it so that both A and B are measured as relatively small displacements off of pi, instead of B being measured as some very large displacement off of pi, going the entire winding around the circle, right? What are we going to do exactly to prevent that from happening, right? And so what we want to do is we need to come up with something called a neighborhood operator, okay? So we need basically a neighborhood operator. And what a neighborhood operator is a neighborhood operator is something that takes two of the values that you want to talk about in a particular space and produces their closest possible proximity, right? Meaning, in our case, we don't really necessarily, in some cases, like for example, when you're working with quaternions, when you use neighborhooding in quaternions, you actually care about producing the actual value that is being neighborhooded. In this case, you could almost say we don't really care about that. We only really need the result of sort of the neighborhood operations to be differenced. And so if we were to say that this neighborhood operator, let's say, was n parentheses some angle, right, that we're passing in here, and what we wanted to have that do is, two angles. And what we wanted to have that do is say that when it comes out, we get whichever one of these we wanted to define as being the one neighborhooded, maybe it's the first one, we get out a theta prime, which is guaranteed to be as close to phi as it could possibly be and still mean the same thing, right? So in other words, if what we put in there was something that was wound all the way around, like this, and we wanted to neighborhood it, right? So like, or if we just had A and B, right? What we would want to get out for an A prime right, would actually be negative, the negative version of A, right? It would be the one that winds all the way around and comes back here, so that A is as close to B as possible, rather than A being very far away from B by being encoded as a positive winding, right? So you see how that would work if I said I want a neighborhood A and B, and I want you to produce a new A that's in the neighborhood of B. What I would want to do is take that A, which is currently positively wound, and wind it negatively, even though that's a larger negative value than negative pi. When subtracted, it produces the smallest distance between the two, right? And so what I was saying here is we don't actually need a neighborhood operator technically, because we never actually care about producing that A. So really all we want to do is sort of a neighborhood distance, if you will, right? So what we want to do is something which essentially says, I want to take the neighborhood operation, right? I want to do the neighborhood operation, and then I just want to subtract whatever the neighborhood is, and then take that as the result. That's all I really needed, right? And so I never actually need to produce the neighborhooding operator. I only really need to produce its distance. And so that could also actually make things potentially a little simpler for us as well. Like I said, sometimes you do need to do neighborhooding. In this case, I don't think we actually do. The time that you have to do it is when you are doing interpolation, because then if you can imagine us trying to interpolate and we wanted to go smoothly from B to A, we would need to actually produce that negative A and know where it was so that we could interpolate to it, because simply getting the distance between them is not actually going to be useful, right? But in this case, we only care about that distance. So how do we do that, right? How do we actually figure that out? And what I assume we would like to do here is we could probably assume, right, that for any value that's positive, we know that if we know that all the values are in the range of pi to negative pi, which we can do, right? We can say that everything has to be in the period range, right? If we know that, then when we look at these guys, we can simply say, okay, positive and negative values are always neighborhooded to other positive or negative values, right? Because if I have any positive number, there's no way to pick up two positive numbers where the negative version of that number would actually have been closer, right? If I have these two guys here, or even like this guy and this guy or whatever, there's never a case that moving this guy onto the negative would actually make him closer. Because the furthest apart they could ever actually be, right, would be on the poles on either side here. I could never actually get them any closer by making a negative. I'm only ever getting them a little bit further away, right? So what we really need to do here probably is just test the signs, right? If the signs of our numbers are different, then we know that they are not in the same neighborhood potentially, right? And if they're not, so we probably, what I'm assuming anyway, what we want to do is say, okay, first we could say we want to see if the signs of the two numbers are the same or different. If they are different, then we're in a situation where neighborhooding may help. If they're the same, then it wouldn't, right? However, now that I think about it, we may not even really need to do that. That's actually perhaps really a little premature. So let me just talk about what we will do to them at that point, and then I can say probably we don't actually ever need to do the check because we can just skip it. Anyway, so let's say that we did have two numbers like here where we've got a positive number and a negative number. And what we want to do is we want to say, okay, we've got B and A, and we want to figure out how far apart they are. We see that their signs are different, so what we want to do is change one of them to be the opposite sign, right? So we want B to become positive even though it was negative. And it's pretty easy for us to do that, right? This negative winding here, right, like so, is really just the positive distance around, the full positive range, which is pi, plus however much that distance, this extra amount is here, right? So if I took negative pi, or I should say rather, if I took B, right, which is this position, and I said I want to go from this negative pi to B, right? So that'd be plus pi, right? It would be minus pi, if that makes sense. I'm going to start from negative pi, and I'm going to go to B, right? So B minus pi, which is plus pi, right? So what I would get there, if I do that, is a positive winding that's this far, right? That's exactly that far. However far it would take to get from here around, right? And what I want to do then is say, well, in order to get there in the first place, I would have had to have gone pi, right? In order to get to the starting point. So that would be plus another pi, right? And so lo and behold, what that actually is, right, is just b plus the full range, right? It's however much the range is, which is 2 pi, right? So it's just b plus the range is what maps b from a negative number into a positive number, right? Does that make sense? Okay. So that's pretty easy. The other question is, well, okay, let's say we had a number that was positive. So this is for a negative, right? For a negative, this is what we would do. We'd take b and we'd add the range, right? Now, what would we do if we want to do the opposite? If we wanted to take a positive number and move it into the negative, how would we do that, right? Well, same thing, right? If we wanted to make it negative, what we do is we'd say we'd start here. We want to figure out how much that is. How much is that? Well, it's going to be going to a, right? And it's going to be going to a from pi, right? So it's minus pi, right? Does that make sense? Starting at pi, going to a. But of course, to start at pi, to start at negative pi and go there, I would need to have subtracted pi to begin with. So it's another pi subtraction. And hey, guess what? It's a minus the range to do the positive version, right? So we have our positive version is this, our negative version is this. And so really all we're talking about here to do the neighborhood operator is just to say whatever the value is that comes in, right, in terms of our neighborhooding, right? Whatever the neighborhood, and this is not really a neighborhood operator, I shouldn't say, because, I mean, I guess I'll write it out the whole one just for fun, right? So if we wanted to do neighborhood of theta and phi, right, then basically what we have is we have a two-pronged thing. We have, in the case where theta is less than 0, right, and also phi, so do it this way, and phi is greater than 0, right? So trying to think of how to, you know, I gotta admit, this is kind of strange. This has nothing to do with what we're talking about, but I realized I've totally forgotten how in regular math notation you write and. I only ever think about things in C now, and like, you don't write it that way, right? You write a different, you write like a different symbol, right? There's other symbols or something for it. Wow, pseudonym 73, if you don't mind, if you're on the stream right now, if you could remind me at the end what it is, it's totally like, it's fallen out of my brain completely. I only think of and as that, and that's not a math and at all. All right, anyway, ignoring that, sorry to go down a tangent there. So we have basically a case where they're separated, then we need to neighborhood. Otherwise, you know, basically in any other case, it's this, right? We can just return it. So if they're the same sign, it's fine. If they're different signs, then really all we have to do is say, okay, I just need to know whatever theta is, I'm going to add the range of the thing times whatever the sine of theta is, right? Because if the sine of theta, well, actually I shouldn't say, I'm going to subtract the range times the sine of theta, right? Because if it was negative, I want to add the range. If it was positive, I want to subtract the range. So really, this is the entirety of the neighborhooding that actually has to happen. So what I was saying before is we don't actually have to produce this. We only have to produce the actual difference between the two. And since we only have to produce the difference between the two, we can actually just do both of them, right? What we can do instead is just say, all right, what is this? You know, what's this distance, right? So that's difference 0, right? And then we can also do this one here. We can also say, all right, also give me, you know, theta minus the range times the sine of theta, right? We can also do that minus phi, absolute value, and that's the other distance. These are the two candidate distances, and then we can just take whichever one of them is less, right? So we basically don't ever actually have to do any checking to see which one it is. We could just produce them both and then take the max, right? Or the min, rather. So we don't actually need a branch if we don't want one. We could write one. It doesn't really matter one way or the other. This is not probably explicitly that expensive, right? But just wanted to point that out. All right, so anyway, if we wanted to add this periodicity to our asset matching, right, then let's open that up. Here's Handmade asset. What we want to do is we need some understanding of what those periods actually are, if that makes sense. And so what we can do is say in that asset, you know, when we have our tags here, we probably don't need a period for every tag because really it's just the tag type that determines it. So really all we need to do is have something in here that's like tag period, right? And the period, or I guess it's actually half tag period, maybe is what we would say, or half tag range. And that half tag range is basically when we go in to the asset tags, we have those IDs. We know that we can only have tag count of them, so we really just need to store them once for every type of tag that we might have, and then we just set it, right? And so what I'm going to do, since most of the time I think we don't really care about this, it's only the periodic ones which are going to be less frequent than the non-periodic ones. What I can do here is just say, okay, when we initialize the game assets, I can just go through the tag types, right, like so. And for each tag type, I'm just going to say that the half tag range of that tag type is always going to be some very large number, right? It doesn't really matter what it is, just something that we're never ever going to type in, right? That's just not going to happen. It's not something that we'd ever actually have, right? And so when I set that, then what I can do is just for the few that I actually need periodicity, and we don't know what those are ahead of time at the moment, but we know we have at least one so far, so we'll set that one. We know for something like facing direction, we know that it's just pi. That's how far it goes in either direction. And so if we have that now, what we can do is we can use that whenever we do our tag matching to make sure that now we actually match in a reasonable way, right? So here's our best match asset. When we actually do our difference here, what we want to do now is actually take that neighborhooded difference. So what we're going to do is do something like this. You know, we can have an A value, right, like so, and a B value, like this. And then the difference is going to be A minus B. But what we would like to do now, I don't think we have a function for sign, so I might just do, since we don't really care too much in here, let's see here. Oh, sign of, there it is. So we could actually use sign of. You can see at the moment it's not a particularly good implementation. It actually does the if here, although I don't know the compiler might be smart enough to fix that. And that's also an int. We don't have a sign of for the thing. So I think I'm just going to do the simple if. I'm just going to say if A, basically, well, you know, I'd have to checking the sign of the two different things to see if they're, yeah, I don't know. Maybe I will write it in terms of sign. Now that I think about it, it would be a little annoying. So I'm just going to assume that someday we'll implement a better version here, right? And there we go. So now we've got a sign of. There we have it. So I'm going to go ahead and say the sign of A. I'm going to take that assets. I'm going to say the half tag range of whatever the tag type is, like so. So whatever the tag type is, the half tag range of that, we want to add the full range. So now that I think about it, actually, we could just store tag range, because do we ever actually, just because it's plus and minus? Yeah, okay. So maybe we just want tag range. We take that tag range, we multiply it by the sign of A, right? And then we're going to go ahead and subtract from that, right? Like so. So that would do our neighborhood for us, right? That would pick the other version. So what we can do here is do, like I said, a D0 and a D1. Here is our new A value, and we can subtract B this way, like so. And then I'll go ahead and roll those absolute values up in here so that we have them, like so. Oops. So that will produce our two differences. And then what we can do now is we can just use whichever of them is the least, right? We can say minimum, and then when we use that, that will give us a better match, right? So now let's change this back to tag range, like so on. There we go, and we can switch it to tau32, which I know that was people were excited about that. Well, okay, one person I think Stellar7 was really excited about tau. So, let's keep it going. Let's keep the tau rolling. And so there we go. So let's go ahead and step into this so we can see how that works. We want the asset group stuff. I don't know if that's loaded here. Game assets, of course it's not. So let's go ahead and open it up. Handmade asset.cpp. Here we are, handmade asset.cpp. Let's take a look at that matching. We'll go ahead and step in here. So what are we matching against? We're matching 0 and 0. Not particularly interesting at the moment. That's okay. So we take the difference between those two guys, and unsurprisingly, that's going to be 0. And then this guy is also going to, well, and so we can see it doing it here. It's producing the other possible difference between the two values, which is a full tau, and that's correct. So then we're going to take the minimum of those two, which should still be 0, and off we go, right? And then we take the weight, we weight it, and compute the total diff that way. So I think that's probably more correct now in terms of tag matching, and so we should get a nice, and we do a nice directional feel to our guy now. And so now we're loading the correct assets periodically, and we haven't actually done anything which prevents us from using aperiodic assets, so that's also good. So that's really what we needed to do today. So we're kind of done. We've got a half hour though, so I'd like to start working on some other stuff. One thing that we have that's left over that we need to fix is the fact that we currently are not actually, we didn't go ahead and do our displacements there. We still have those displacements happening. As you can see, the shadows are in the wrong place and so on. That's because we had those displacements encoded in here like so, and we've never actually gone ahead and backported those displacements. So what I'd like to do is I'd like to go ahead and just see what that standard displacement actually would be. I think I can just, since it's the same, it looks like it's exactly the same for everybody. It's 72, 182 for basically all of them. What I'd like to do is just take a quick look and see if there's any reason I can't just use the same one for everybody. What I can probably do here is something like this, just for the time being. I think you can do something like this. I don't actually remember. Let's go to debug load bitmap. That actually takes a line percentage. So top down a line. Okay, so I wouldn't quite be able to do it that way. What I would have to do is something like this. Loaded bitmap, temp array. Who knows what that is? Or, you know what, I guess, like, well, meh. All right, let's do it this way. Let's do file name, like so. So what I'm going to do is I'm just going to grab all these files. I'm going to shove them in here, right? Like this. Pretty simple. We could even, because we've got time in the stream, we could even go nuts. Something like this. Something that was absolutely ridiculous. And then I don't even want to know what I just did there, but Emacs macro that up. There we go. So now we've got all of these guys in a file name array. I can go through each of them. I can go ahead and load them. Loaded bitmap equals debug load bitmap. And then I will take file name. You know, I ordered a 10 keyless keyboard recently because I'm really anxious to try it out. I hit the stupid insert key all the time, the 0 key. I'm really looking forward to that not happening. I never really want to be in overwrite mode, almost never. So yeah. All right, so anyway, let's go ahead and finish this up, file name, ++i. So there's our bitmaps that we're loading. And then I can do a top-down align of these guys just to see. Top-down align, loaded bitmap, and v2 align x over this, so it does the safe ratio, which is what we wanted. So here's that. So that will produce that top-down align for us. This is basically a no-op here, so just to give us something to break on. So that should do it, right? Let's see. Oops. Top-down align. There we go. All right. So now if I go ahead and take a look at what those come out to be, I can see the thing that I actually wanted to see. Of course, no, I can't, because Visual Studio is fighting me every step of the way, as it always does. You cannot see bitmap because it's undefined. Okay, thank you so much. So that's wonderful. I guess I will actually have to do something here just to make the debugger not be awful. Okay, there we go. Now, taking a look at the bitmap, here is the actual line percentage. It's a 0.5.5. Wait, what happened there? Shouldn't this have set it? I don't understand. Why am I still looking at a 0.5.5? That doesn't seem right. Does that seem right to you guys? This doesn't seem right to me. I want to know what happened there. Let's go ahead in here. All right. So we've got those set. We call top-down align. Oh, it doesn't work the way I thought it does. Oh, did the stream go down? It says reconnecting. That was pretty weird. Well, I don't know what just happened, but I'm going to keep on going. Don't know if that was me or if that was Twitch. Twitch has been acting really strange lately. Let's ignore it and keep going. Anyway, so top-down align. Just do it this way. And now I can start getting those values out, which is what I wanted in the first place. Okay, so let's take a look at the result. And now this is looking a lot better. So it's let's just save these guys. We've basically got a 0.5 and a 1.56. So let's see if those are the same, the same. All right. So all of those are basically exactly the same. So that's all good. Nothing weird going on there. So that's all fine. So all I really need to do then, I guess I need to actually go back and grab these guys, like so. All I really need to do then, if I want these to be correct, is I just have to make a v2, which is the hero line, and that hero line is what we've read out, which is 0.5 and 0.156, etc. Right? And so now every time we do an add bitmap asset, we can just specify that alignment value here, like so. And I think that's about it. I think that's all that we would need. So there we go. Off you go. And oops. Let's see if that does any better for us. Yes, there we go. So now everyone is aligned properly, and that's all good. And so I think we are now at the point where the asset system is doing what we need it to do. So yeah, I'm pretty happy with that. I feel like, and at least I don't really know at this point. I feel like we're probably at the point where we want to go ahead and, I mean, I feel like we're at the point where we want to start talking about the asset file format now, right? I mean, maybe it's a little premature, I don't know, but we kind of now have a situation where we could reasonably say that we have an asset file format, here's what it is, and here's how we want it to work, right? And we could do that. So I feel like we're at the point where maybe it's worth thinking about that. I don't know. That's just my gut feeling, because we now do all the asset matching that we wanted to do. Like I said before, I don't actually know that we want to ever have anything where we use descriptors in the asset file format. I think we want that always to come from the code side. So it kind of feels to me like that may be the end of it, right? That kind of feels to me like that may be it. So let's see here. Everything feels pretty smooth. No issues. Yeah. So I think we're good. I think we're in good shape. So yeah, so I'm trying to think now, handmade.h. So asset streaming is basically in. There's a little bit more we would want to do. So let's just aim for kind of finishing this guy up, right? And in order to do that, I think we want to do a file format, right? That we load the assets off of disk. And then we have to do our memory management to make sure that we don't have stuff sort of willy-nilly. And then I'm trying to think if there's anything else we really want from the asset streaming system, or if we can just check that off as being done. I can't really think of much else. You know, if we have to optimize it later, we have to optimize it later, but that's not something we have to address right now. What we could do, I suppose, is before we do the file format, actually, you know what we could do? Maybe we start on audio, right? Maybe audio is a good idea. Maybe we bring that up here, and we basically say, let's get these two guys done together, because if we don't have audio in the asset loading stuff, then that would be that would be a problem, obviously, right? So we've got about 20 minutes left. Maybe we'll throw in audio loading so that we know that that's actually working. And then we could go ahead and do the file format once we know that it would support both audio and video. That seems pretty reasonable to me. All right, so if we're going to do that, we already did part of what we need to do for that, right? We have asset slots for sounds. What we don't have at the moment, and we also have tags for sounds, right? What we don't have at the moment is actually any way to load a sound, right? We don't even have anything like that. And so when we have something like load bitmap work here, we have load bitmap. We basically want to make an exact copy of this conceptually, but instead of doing it with bitmaps, it would do it with audio. So instead of doing the work necessary to load a bitmap out, it would do the work necessary to load a piece of audio out, right? And so what we want here is something that, you know, looks basically like exactly the same, you know, something like this, where it does this, but for sounds, right? So here's sounds. Here's the ID value for them. We set the asset state of them and does exactly the same thing. We then begin a task for it. You know, we get the task out, but instead we would do like a load sound work here, and then we would just fill out exactly the same stuff. Only it would be instead of a bitmap or something like this, it would be something else entirely, right? So yeah, that is what we would want to do. And I feel like that's really, that would really be it, right? So what we need to do is have a thing. We've got loaded bitmap. Let's take a look at the renderer there. Here's loaded bitmap. We've got loaded bitmap, and what we really need to do, I suppose, is make an equivalent for audio, right? And so we would need something like loaded bitmap for audio, right? We would need something like loaded sound, you know? And that would probably be something that just told us what the sample count was, right? Like that. And it would be, you know, something which, which was just like how many samples, and then the memory for the samples, right? Something like this. I feel like that's all we'd really need. because all of our sound samples, all of our sounds would be in the same format, presumably. So there really wouldn't be much else that we would need to do. So yeah, so I feel like that would be basically it. Yeah, I'm trying to think if there's anything else. I also think we may be able to do some collapsing here of stuff. There's more stuff we'll be able to do a little bit later, but for now, I think it would be something like that. And so yeah, so as we do this stuff, we would want to have that work order be something like this, right? And this guy would just be, you know, a loaded sound star, like so. And looking at it there, it's really, they're really so close. I feel like maybe we will end up collapsing these. I'm going to leave them as separate things at the moment, but I feel like they may end up being so close that we just collapse them down into one thing. You know, it's really hard to know sometimes before you do something how different two code paths are going to be, but when they start to look much like compression-oriented programming, you know, approach, you just want to look and go, oh, these two things are working exactly the same way. Maybe I can merge them together and make, you know, less code. That's always a good thing. So, okay, if we do something like this where we have a load sound, we pass it the ID, we go ahead and do this stuff. What we would want to do now is we would want to, wait a minute, that should be, there should be a sound, this should be like sound ID, right? Sound ID. Do we have that yet? We've got bitmap ID. There's audio ID. I don't know, it shouldn't be audio, it should be sound ID, right? There we go. Sound ID, like so on. Okay. So when we load that in, that would all be good. And then we just need the actual function, like this guy here, which actually does the sound loading, right? So we need something that does like load sound work, right? Like so. And what this would do is this would, you know, do the equivalent of what the bitmap thing does. It would say, all right, we have a sound info structure, presumably, which is exactly the same as the asset bitmap info kind of thing. So like this, it's sound info. At the moment, it would probably also just be a file name, right? Asset sound info, sound infos, like so. And we want to grab out whichever one that is because that's the one that we would actually use. So there's our work ID value, right? Blah, blah, blah. We would then go ahead and say whatever that one is that we're loading here, the sound. We'd probably have a debug load wave file for something like this, right? We would grab out just the file name from the info. We'd do that, and then we would, well, that would be the end of it, right? We'd set the sounds like this, right? So we'd say something like this, right? So the slots, the asset slot has a loaded bitmap in it, and so at the moment this would actually be something like this, right? So whichever one it is, that's what it does. So it would be something like that. That's really what we would do. We don't have that loaded sound structure yet, really, but we're just going to pretend that we do, and then we'll work on building one a little bit later. So let's just go ahead and debug this here. And that's the wrong type. Debug load wave. And so really all we really have here to do is actually have a debug load wave, which is something that would be the equivalent of debug load bitmap, but for wave files, right? That's all we really need in order to sort of get this started in its basic form. So let's go ahead and see. We've got our debug load bitmap function, or at least I thought we did. Oh, right, it's in here now. We've got our debug load bitmap function, and so what we want to do now is do, you know, a version of that for wave files that's going to do exactly the same thing. So let's see if we can just start to bang a little bit of that out as well. So we want to do essentially the same thing here that we were doing before. If we want to make one of these, There we go. We want to basically do exactly the same thing. We want to do a debug read entire file. We want to see if we actually get anything back. If we do, then we want to take the contents and start to look at them as an actual WAV file. Now, WAV files are a little bit more difficult to read than BMP files, but not by much. I'll go ahead and bring up the docs here for it. WAV file format, right? And here we go. Let's see if we can get a reasonable documentation of them here. Let's see. So this will probably do. Let's see what we have here. Multimedia player. Let's see. Do we want all of that? Pages 56. Wave update. I don't know that we really want all of this stuff. This I guess looks like a pretty. Maybe we'll just use this web page. I don't know. Seems okay. Anyway, so the way that WAV files work is there's this concept of a chunked file format. And these show up, I don't know if the first one of them, I doubt it was really the first. But there was a thing called the IFF format, right? And it was I think Electronic Arts made it. It was by Electronic Arts, and it was on the Amiga. And this is the first one that I ever remember seeing that worked this way. I suspect there were ones before it because it just seems like there probably would have been, but I just don't recall any of them. And basically the way that they work is they try to create a generic way of encoding hierarchical data, basically. So what they do is in the file now, remember exactly like a bitmap, this is just in the file, there's bytes in the file. What they do is they encode like an ID, and that ID is usually, in these cases, it's 4 bytes is the way these work. And the 4 bytes are mapped to actual ASCII characters typically. So there'll be things like WAVE or something will be the actual ID of the chunk. So it's not like 0, 1, 2 are the IDs. The IDs are actually often 4 different character values packed together. So this is some crazy, big, huge number if you looked at it as a 32-bit integer, because it's actually the 4 bytes of wave, right? So typically what they do is they have an ID of a chunk, and then they have a size. And what you would typically do is the way you write a file parser for one of these is you look to see what the ID is, and then you look to see what the size is. If you understand the type of ID that you see, so it's one of the ones in the set that your program understands, you then parse out, you'd like, go start processing the bytes that are size amount of bytes in the file that come after that chunk. If you don't understand it, you just skip that section, right? Because you know how big it is because of the size, and you read the next section. And that section also has an ID and a size, right? Now inside these, you can also have, if one of the definitions of the chunk is that it's got subchunks, then inside them you can have more little IDs and sizes, right? That have other stuff. So you can basically just imagine this sort of hierarchical structure that you can create with these things. It's not a particularly good way of doing a file format. I definitely don't recommend it. It's an old school way of doing things. You can almost think of it as like HTML and binary. Better than HTML because at least it's got sizes and can encode binary data in a sane way. But it is just a little bit janky, to say the least. Anyway, so if we go ahead and start to parse this, what we would need to do is start by taking a look at what the typical WAV file has in it. And again, we don't have to do anything robust here. We don't actually have to read all WAV files. We just have to read something so that we can use it for our debugging, because we'll assume that our asset processor is the thing that would do any of the fancy reading and putting assets into the format that we want. So this is only our debug loader. So just like the bitmap loader, it only has to load some example assets that we would use. So if we wanted to do that, this is the specification for what happens at the beginning of the file. You can see it's little endian order, so that's kind of handy. And you can see what we've got here is we've got a 4-byte field that should say RIF. we've got a 4-byte field that says how big the chunk is, and then we've got a 4-byte field that just says wave, right? That's what we should see. And so I'm going to go ahead and assume that that's true, and I'm going to make a wave header here. And you can actually, I believe this is all of the chunks in the file will have this kind of format, right? So let's see here. They have chunk ID, and then they have chunk size. No, I guess they're different. So I guess typically they only have ID and size. This one has ID, size, and ID, right? If that makes sense. Whereas normally that's not the case. So all right. So let's take a look at that and see what we've got here. So we've got our wave header. Our wave header should have a chunk ID, right? So let's just do this as a UN32. This is the riff ID. Then we've got a size. Then we've got a wave ID, like so. Then we've got another chunk that we might see is this chunk right here. And so let's put in that one as well. That chunk would basically be all of this stuff. So we have a format tag that's 16 bits. So we have FMT here, like so. So we have uint16, that's a W format tag. We have a uint2, so another 16. That's the number of channels. We have the samples per second. So we have n samples per second. Oops. Come back. We've got the data rate, average bytes per second, which we don't really care about. That's just two of those numbers multiplied together, probably. Block alignment and block align. Not sure what the actual meaning of that is. We'll have to take a look. Bits per sample. Bits per sample. So CB size. We don't actually care about size of extension, I guess, but we'll see here. CB size. Valid bits per sample. 16. Let's see. W valid bits per sample. DW channel mask. So DW channel mask. And the subformat, which is a GUID. Is that, how long has that been in there? Huh. Well, we don't care about that, but fine. There's a 16-byte subformat, we'll leave it in there. All right, and so then here are the different formats, I guess, that you can be. PCM is going to be the standard, that's what we'll read, and these guys will be other things that we won't actually be using. So we pretty much only need to look for that actual format. Okay, so what we want to do here is put in one more thing, which is the wave like chunk, if that makes sense. And that, as we know, is like 4 and 4. It's the chunk ID and the size, right? So if I go ahead and say we've got the ID and the size, like so, then what I would do is read one of these, see what it was. If it's the format chunk, you know I use it, whatever. Okay, so the chunk ID has to be FMT. So what we want to be able to do is we're going to want to be able to compare as we read these chunks out of the file to see what these ID codes are. And so what we want to do is have a way of making a bunch of those, right? So we want to do something where we can actually have like a wave chunk ID FMT, like that, you know, wave format, you know, riff, something like this, like, you know what I mean? We want to be able to do that. But we can't just do this, right? Because you're not actually allowed to do that in C. You can't say, give me a 32-bit value that happens to be FMT. So what I need to do is something like riff code. I need to make a kind of annoying macro, basically, which would allow us to make these in some kind of convenient way, right? And so what I'm going to do is define one that basically just takes these char codes, like so, and for each char code, it'll just put it in the correct position. Now, I don't know what order they're talking about. I'm going to assume, since it's little endian, that the F comes first, but we'll be able to see once we go read the file which one's going to be correct. So we may have to change this macro around once we actually see it, right? Whether it's 24 or 0 shift up here, if that makes sense. So anyway, if I go ahead and do this, then I can make, I'll go ahead and parenthesize these. It's a macro just to be extra safe. There we go. And maybe I'll even be double safe. I'll cast them to uint32 since that's what we want this to end up being all the time. So there we go. So if I make these riff codes now, oops, now we actually have a way of specifying riff codes in the native way that they're specified, which is as character strings, which just makes it a little bit easier for us to read and define new ones potentially. So there we go. And so what we would want to do here is we would want to start parsing this guy. We would want to assume, I guess generally speaking, that we had, you know, like a wave header here, right? And that wave header, we would expect to see that its ID field, right, would actually contain that riff chunk header, right? So we'd want to see this in the riff ID, like so. We would want to see, in addition, the wave ID being in there. And assuming we saw both of those, then we would be good. We could, I guess, assert those. I don't know what our convention was in our bitmap routine. Did we just assert that those things were true? Yeah, we did. So maybe we'll just do assertions. Again, this is not supposed to be real loading code. This is just for our own debugging use. It will never happen on the end user's machine. So we want to assert that those are true. And then we would start to look through the chunks in the file. Now I think we don't have any time left, so I'm going to leave it there, compiling. And tomorrow we'll go ahead and we'll actually get a wave file loading. And that will put us in good shape for, again, finishing up the asset loading, but also we'll probably be able to finish up that audio stuff as well. And that'll be good. That'll get us down, again, to some nice, get down to some much less to-dos. Because we do want to keep, like I said, I'd like to start working on game code around day 200. And so I think we're on good track to do that there, but there's a couple things we want to be able to cross off, right? I want to be done with the stuff above this line, basically. I don't want to be doing any of these sorts of things that are purely engine work and have nothing to do with game code. I don't want to be doing those much past day 200 if we can avoid it. Of course, it's software, which always goes long, so maybe we will, maybe we won't. But the idea here is just that this stuff I'd like to kind of get done. And we did most of the rendering work that we needed to do, but we still have two sort of big ones there that we want to tackle. The debug code's relatively straightforward, but we do need to get fonts. So there's a fair bit of work in here, right? There's a fair bit of work in here that we would want to do. And so, yeah, like I said, I'd like to get these guys checked off since we're within pretty good shooting distance of getting them done. All right, so let's go to the Q and the A in case anyone has any questions. Let's take a look. And also the stream went down, I noticed during, for some reason. I don't know whose fault that was. I'm assuming it's Twitch because Twitch doesn't seem to be working at all today, but I don't know. For getting this character sprite, couldn't you just do the following? Let's see. Couldn't you just do the following? Int sprite to load equals angle plus 180 over sprites divided by 360 over sprites mod sprites. No. So there's a bunch of things that doesn't do, right? First of all, who is doing that? Is the asset system doing that? If the asset system's doing that, we need to start storing additional information, which is how many sprites there are at particular angles, right? But we're not doing, like right now, our system has no concept of specifically uniformly distributed things around angles, right? You could have something that has, you know, a very dense set of angles in one area and then a much larger, sparser set in another area, right? If you want like a boss monster, for example, who only mostly looks forwards, and then so there's a bunch of different ones of him looking forwards, but then hardly any of him looking backwards, our current system just works now. Whereas quantizing it would not work at all, right? Because you wouldn't have anything to quantize it to. Does that make sense? Chronal Dragon and I had a combined question about the audio asset struct. Will it need a sound loopable or loop start loop end with loop end equals -1, meaning a one-shot sound? So I don't really know yet. Probably. But since we haven't really built out any of the sound system stuff, we don't really know what that'll want. So probably what we'll do is we'll write the mixer, and then we can go in and backport any stuff that the mixer actually wanted into our asset system. Plans for implementing other audio formats like MP3? No, we definitely won't implement MP3 because it's patented, so we're not allowed to. We could implement it maybe in, I think, 2016. The patents may expire, but it is actually against the law for me to implement it. That, ladies and gentlemen, is the wonder of the US patent system. One of the worst ideas ever, software patents. But what are you going to do? So yes, I cannot show you how to implement MP3. That's against the law. Or more specifically, the instant that you were to download the source pack that contained the code I wrote to play the MP3, that would be against the law. I suppose on the stream it may not be against the law for me to just tell you how to do it. Og Vorbis we could theoretically do, because in some in theory it's patent free. I don't know that there's really a whole lot of reason to do it, because it would take a lot of time and it would basically just be about reducing our download footprint a little bit, which I don't know that we care about. You know, maybe we do, maybe we don't. It depends, I guess, also on how much streaming overhead we have in terms of disk. You know, maybe it would save some bandwidth. FLAC is pretty useless because FLAC only gets you like, it doesn't even get you like 2-to-1. So I don't really know what the point of FLAC is. FLAC doesn't seem like it's very useful, because if for some reason you need to compress your sounds, you probably are trying to save space, right? And 2-to-1, less than 2-to-1, is not going to do it for you, right? So you're probably looking at something like Og Vorbis if you really need to do that. But those would be very lengthy, I think, to do. So I don't think I'm going to do them because they would take up a huge amount of stream time for not really very much benefit. It's just a size savings. Cooper Caleb says, wait, how exactly is MP3 patented? MP3 is covered by literally dozens of patents. If you would like to see what they are, you can use the first hit on Google for MP3 patents, and you can see them all. Here are some of them, and when they expire. You can also see, let's see here. Where's the patents? Here you go. So you can read about it here, a bunch of stuff, and you can see right here. There's, you know, basically the United States leads the world in being absolutely ridiculous with software patents, and so you can see that, you know, we're kind of messed there. It looks like, so if you believe what this part of Wikipedia says, in different parts of the world, it may be that the patents elapsed in 2012. And so, you know, in your part of the world, it may be legal to make code that uses MP3. I don't know. But in the US, it's not. So yeah, the theory is maybe by September 2015 it would be, but maybe not, because I think it could also be 2017, right? We don't know, you know, we don't really know. So. Kubernetes, they're not patenting the file extension. They're patenting the techniques that are used to create the audio and to encode and decode the audio. And so if you want to parse what is in that file, you violate the patents just by the act of parsing them, because that is what is patented, right? Like I said, I don't agree with it. I think software patents are absolutely ridiculous and really have no place in modern society. But unfortunately, I don't make the laws, and I have to follow them. And so we can definitely not read an MP3 file. As for the person who says FLAC is 50% the size of WAV, it's not 50% the size of WAV. Best case, it's 60% the size, if I remember correctly. And that's best case, so oftentimes it is not. So let's take a look here. What is FLAC compression rate? Let's see. Yeah, so, I mean, I would say in general, well, that says typically, so maybe it's better than I thought. I thought that was best case, meaning you rarely saw anything that would go before it, but maybe that's not true. FLAC, do we have some kind of a article that tries to see? Yeah, so this is more like what I expected to see, right? So very little compression, really. And so if you were trying to save, you know, if you take a look at this, right? Let's say your footprint, you know, for your total game is 2 gigabytes or something. How much of that is audio, right? If the answer is out of that 2 gigabytes, a half gigabyte is audio or something. I don't know. I mean, pick whatever it is. A half gigabyte's audio. If you take that half gigabyte and you're saying, okay, I could compress that and save 25% of it, right? You're talking about a savings of something like 100 megabytes in a thing that's 2 gigabyte redistributable. Why would you bother, right? You're just adding a bunch of code to your game for really no significant savings, right? Even halving the size of your audio, which looks like this is more of a good case. Instead, this was the bad case, I guess this is the good case. Even halving the size of your audio, it just isn't that useful. If you're trying to get stuff down, you need to get it down a lot more than that, right? You need to be able to get it down like, 4:8:1, something like this, before you're talking about something that's really in the ballpark of useful compression that changes the use cases that you could actually ship this thing in, right? That's just my opinion. So 50% is just not enough. I feel like 50% is not enough to actually care about that compression. Maybe I'm being too stingy there, and that's best case, right? A lot of times you're not getting that. So it doesn't seem like a very useful thing to me to introduce all that complexity just for that. I think if you're going to introduce all that complexity, you should pick, again, something like Og Vorbis, where you're going to get 8:1 or something like this at least, and you can tune it a little bit more so you can actually get more than that if you want, right? And Kubernetes, yes, that is why Rad doesn't patent any of their stuff, is because we didn't believe in it. We believe that it's stupid, so we don't patent it. All right, looks like that is the end of the questions. Okay, I will wind things down. I'll leave that WAV file specification up for now because there's some other chunks we're going to want to get. We're going to need basically the data chunk at least. So yeah, I'll leave that up. All right, let's go ahead and close this down. Okay. All right. Double check to see if there's any other questions. No, it doesn't look like it. The stream was so... I feel like twitching is being very twitchy today, so I wonder if maybe we probably wouldn't have enough people who were able to actually catch the whole stream to ask questions. Hopefully tomorrow things will be better. And I can double check to make sure it wasn't my ISP or something, but I don't know that it was. Anyway, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can pre-order the game on handmadehero.org, and it comes with a source code, so you can go ahead and play around and experiment on your own. If you want to do that, you just use the little handy-dandy pre-order button there. If you want to just support the video series separately, you can always do that by subscribing to our Patreon. We also have a forums page where you can ask questions and look at ports to Mac and Linux, and check out an annotated episode guide that helps catch up on old episodes. We also have a tweet bot that will tweet the schedule at you, so if you want to subscribe to that to catch the live stream, that's a really handy way to do it. Check out all that stuff. Hopefully there's good stuff there that will help you out. Anyway, thanks for joining me. We'll be back here again, same time, same place, 5 p.m. Pacific Daylight Time tomorrow, right here on Twitch. I hope to see you all there. Until then, have fun coding, and I'll see you on the internets.